All right, chapter 3, problem 47. A football player punts a ball at 45-degree angle without any effect from the wind. The ball would travel 60 meters horizontally. What does this mean? It would mean it would go up and come back down 60 meters later, right? 60 meters. My beautiful handwriting. All right, that means in the middle at 30 meters, right? At 30 meters, it's at its peak. That's what that means. At 30 meters, it's at its peak. And at that point, if you remember, at that point in y, we start off with initial velocity. We hit our peak, and the velocity in y is actually 0 at the peak. All right? The velocity in y is actually 0 at the peak. So let's play around with the equations for velocity and see what we get. All right? So velocity in y is equal to the acceleration in y times time plus the initial velocity in y. Now we don't know the initial velocity in y, right? All we know is that the initial velocity is at 45 degrees. So whatever this v naught is, that means the y component is going to be v naught times the sine of 45 degrees, and the x component is going to be v naught times the cosine of 45 degrees. All right? So we know v naught y is v naught times the sine of 45 degrees. We know ay is ay is minus 9.8 meters per second squared, right? We know when it reaches the peak, Vy is 0. Okay, so this doesn't get us all the way to where we need to be, but it does get us to 0 equals minus 9.8 meter per second squared times the time we reach the top. I'm going to put top there so we know time we reach the top plus v naught sine 45 degrees. Okay, so we could write this a little differently. No, I'm not going to leave. I'm leaving it alone for the moment. All right, so what's happening in x? All right, Vx equals v naught cosine 45 degrees. All right, and Vx doesn't change. Ax is 0, right? And so where are we? We know that when we know from the problem that when we hit the peak, right, we would have gone 30, we would have gone 60 meters. We know that when we hit the peak, we've gone 30 meters. So if we look at the position in x equals 1/2 ax t squared plus v naught x t plus x naught. All right, we can add to our list of knowns. We have x naught equals 0. So when time t top gets there, we're at 30 meters equals, all right, the acceleration is 0, all right, 30 meters equals v naught cosine 45 degrees times the time t top, right? And x naught is 0. Okay. So this gives 30 meters is v naught cosine 45 degrees t top. And we have up above, we have the equation here, right? Which I am going to rewrite. We have v naught sine 45 degrees equals 9.8 meters per second squared times t top. All right, I'm going to rewrite this down here as V naught cosine 45 degrees equals 30 meters divided by t top. Okay, so we've got V naught sine, we've got V naught cosine. I'm going to cheat a little bit because sine of 45 degrees and cosine of 45 degrees are equal to each other, right? V naught sine 45, well, let me just back up. Take the V naught out. Sine 45 degrees equals the cosine 45 degrees. And so we can set V naught sine 45 degrees equals equals V naught cosine 45 degrees, right? So basically V naught sine 45 degrees equals V naught cosine 45 degrees, so the two things they're equal to are also equal. And now this gives us an equation that is t top squared equals 30 meters divided by 9.8, do this, 9.8 meters per second squared. 30 meters divided by 9.8 meters per second squared. Well, the 1 over second squared is going to give us second squared. T top is going to be the square root T top is the square root of 30 over 9.8. Seconds. Put the seconds in there. Oh, that's not where the seconds go. Seconds. All right, square root of 30 over 9.8. .75 or 1.8. 1.7. 1.7 seconds. All right, we hit the top in 1.7 seconds. Okay, so back to what is initial speed of the ball. Now that we know when we hit the top, we go back to any one of these, right? Let's go back to this one. .8 meters per second squared. 1.7 seconds, right? Naught is 9.8 divided by 0.707. The sine of 45 degrees is 0.707 times 1.7, and it all works out to be meters per second. Okay. Equals 9.8 divided by 0.707 times 1.7 is 24 meters per second. 24 meters per second. All right, that gets us to part 1, part A. What is the initial speed of the ball? Now, it says when the ball is near its maximum height, experience a breeze gust of wind that reduces the horizontal velocity by 1.5 meters per second. What distance does the ball travel horizontally? All right, what distance does the ball travel horizontally? So part B. So now Vx is our initial speed, 24 meters per second, times cosine, well, I'll put in cosine 45 degrees, right? Minus 1.5 meters per second. 1.5 meters per second, right? So 25 times 0.707, okay. 24 times cosine of radians of 45 degrees, right? Minus 1.5. 15, okay. So we're now at 15 meters per second. Now here's the beauty of this problem, right? In y, nothing has changed, right? In y, we went up, we went down. Nothing changed in y, only the x problem changed. So how far on the way down do we go in x? Well, we know the time it took to get to the top was 1.7 seconds, right? So the distance we go in the second half of the problem in x is just Vx times t top again, right? Because that's how long it takes to come back down. So 15 meters per second times 1.7 seconds, right? All right, so equals 15 times 1.7 is 25.5, 26 meters. 26 meters. So the total distance we go is the distance in part A plus the distance in part B is 56 meters. That's how far we go in x. And I believe that is the end of the problem. All right, that's it for problem 47. On to the next one.